Right, in 2020, what we're going to do is work through the algebra and complex numbers questions once again. So the first thing here, we have an algebraic equation. Now the key thing in here is write down the lowest common multiple of 2, 3 and 4 outside each. So big dirty brackets around each. And then what's the lowest common multiple? Remember your multiples of 2, 2, 4, 6, 8, 10, 12, multiples of 3, 3, 6, 9, 12, multiples of 4, 4, 8, 12. Now, don't be panicking if you wrote 24 or 36. It's all going to give you the same answer at the end. So 12 goes outside each. And now ask yourself, how many times does 2 go into 12? It goes in 6 times. 3 into 12 goes 4, and 4 into 12 goes 3 times. Now write down what you have, including those brackets. And just multiply out the brackets. Remembering to multiply everything inside the bracket by what's outside. So 6 times 9x, 54x. And I just, before I move it across, I might just tidy up my letters with each other. So on the left hand side, there's nothing to pair up. On the right hand side, 27 and 12x giving me 39x. And I'm just going to bring my letters to the left and numbers to the right. And whatever comes across, the sign changes. So 15x equals to minus 20. To work out x, divide by the number stuck onto the letter. And if you put that in your calculator there, it'll simplify it down to minus 4 over 3. 5 goes into each of them. If you did write minus 1.3, I would just press your SD button because the 3 is a recurrent decimal. There'll be a wee dot above it. Next thing, simultaneous equation. Once again, this is one linear, one quadratic. So you're going to have to work with a simpler one first of all, the linear one, which is up here. So what they're asking you once again, where does that line meet a circle? There's my linear one. There's my circle one. So get your y on its own. Keep it positive, bring it over there. So 3x minus 4 is equal to y. Now you're going to sub it in everywhere there's a y in that second equation there. So 4x squared minus 3x, and instead of my y, I know y is equal to 3x minus 4. Multiply that out. And just tidy it up. From here, I would do my minus b formula. I got my minus 4 from just bringing that 4 across. So my a is the number in front of x squared, which is minus 5. B is 12. C is minus 4. Throw that into my minus b. Just be careful if there's any double minuses or whatnot. Brackets around your b squared. And just type that as you see it. And I get 0.4 or 2/5 is one of my answers there. And let's go back, change that plus to a minus, and I get 2. Remember in this you have to work out your y also. So we said at the top y is equal to 3x minus 4. So I'm just going to sub in each of those. I always have the habit of starting off with the more straightforward one. So my 2 on there. Y is equal to 2. And if you can remember to write it as a point, that'd be great. If not, no worries. Remember your point is made up of an x and a y. And down here, same story. So it cuts it twice, it meets it twice. (1.2) minus 4, what's that? Minus 2.8. So once again, just writing it as your point. Don't be panicking if you forget to do that. Right, simultaneous or complex numbers here now. We're given 2 complex numbers, Z1, Z2, actually, and Z3. So here it says write Z3 in this form. So Z3 is 2i Z2. So 2i multiplied by Z2, which is minus 2 plus I. Multiply that out. Minus 4i plus 2i squared. And remember, a complex number, as it even tells us here, it's in the form a plus bi. So the highest power of my imaginary bit is just 1. So everywhere I see an I squared, I sub in minus 1. And that's what it tells us in the majority of these newer questions. And tidy that up. That's right. I often put the real bit first. Because it's more likely when I'm plotting it, I'll not make any wee silly mistakes. Next thing, we've got to plot each of these. So Z1 is 3 minus 4a. And label it. Z2 is minus 2 plus a. So minus 2 across, I up. So remember, it does tell you there's my real numbers there. Here's my imaginary numbers, the things with i's, my y-axis. And then Z3, there's minus 2 minus 4a. And label it. Then it says find the modulus of Z1. Now Z1 we can see there is 3 minus 4a. So we need to know how to work out the modulus, and we need to know how to do division. Now the modulus, I always say learn the formula square root of a squared plus b squared, or the square root of real squared plus imaginary squared. So it's a square root of 3 squared plus, it's always a plus here, minus 4 squared. Now that's not given to you in the formula book. Throw that all into your calculator and you'll end up getting 5. So what that means is it's 5 units from the origin. So I wanted a graphical representation of that. You know, it's 5 from the origin, 5 spaces. So that's why it's never a negative answer. Next thing here. If Z1 by Z4 is equal to that, write Z4 in that form. So we need to get Z4 on its own. Now, as I told you, if they don't ask you for the modulus, you can be sure they're definitely going to ask you for division. It's the 2 big things, modulus and division. Everything else is straightforward. So to get Z4 on its own, if I had 2x is equal to 8, how do I get that x on its own? I divide it, 8 over 2. Same thing over here. To get the Z4 on its own, since that is a multiply sign and not an add or subtract, I'm going to divide. So it's 29 plus 3i over Z1. Now I know Z1 because it's given to me in the question. What was it? Minus 3 minus 4a, or 3 minus 4a. And now when I'm doing division, what I've got to do is multiply top and bottom by the conjugate of the bottom. So the conjugate of the bottom just means change the sign of the imaginary bit. So multiply top and bottom by 3 plus 4a. And now we're just going to take our time, work out the top. So it's, what is it, 29 plus 3a times 3 plus 4a. Bust your brackets, split your brackets. And multiply them out. 120, is it 116, is it? And everywhere we see the a squared, remember, sub in minus 1. And tidy that up. So that's my top line there. Now do the same for your bottom. And when you multiply a complex number by its conjugate, will always end up with just a number. So there should be no i's left in the final answer here at the bottom. So my two i's there, plus 12i minus 12i, they go. And here I've got my I squared. When I see I squared, sub in minus 1. That gets me 25. And now I'm just going to put them two answers together. And divide it in. So 25 goes into each of them. Again, this is one of your cherry on your top of your cake. So 25 into 75 goes 3 times. And 25 into 125 goes 5 times. So your answer there is 3 plus 5i. So the key thing is divide it into each of them. And that's that.